Hi, welcome to the video on the 1.2 notes, evidence for the age and composition of the Earth. All right, so the first thing is we're going to talk about the two different types of dating techniques, relative and absolute. Let's start with relative. Throughout this video, if you need to, pause it so you can copy down the notes, but I'm going to read them aloud and add some commentary as well as we go so you can get a better understanding of the notes. So as I said, there's two types of dating techniques. We're going to start with relative. Relative provides the relative age, which describes age using words like older or younger. And it's called relative because it compares ages. So it relates or compares to ages. So if you say something is older than something else, then you're having to compare their ages. It is qualitative because it uses words to describe it. It's not using numbers. So qualitative uses words. All right, that's relative dating. So let's look at how we determine relative dating in terms of geological history and the history of the Earth. We use what's called the law of superposition. Superposition. And the law of superposition is when you have layers of rocks like this. The oldest rock layer and objects found in that layer are at the bottom, okay? So the lower the layer is, the older it is. All right, and so clearly when you're looking at the law of superposition in rock layers, it's the position of the object or the rock layer that determines its relative age. And that's why it's called the law of superposition. So again, if you need a moment to take your time to copy this information down, you can pause the video. We're now going to look at the second type of dating. I'm going to cover that here, and that's absolute dating. Absolute dating. All right, so absolute dating provides the absolute age, which describes age in numbers, okay? And it's called absolute because it does not need something to compare it to it. So, for example, if I would say that I'm 15 years old, which I'm not, of course, but if I would say I'm 15 years old, I don't need to compare my age to someone else to state that I am 15 years old. That's my absolute age, no matter what the age is of someone else. Now, because it uses numbers, it's called quantitative. Quantity, how much, right? That's number. So quantitative, because it uses numbers. So that's absolute dating. Let's look at some of the techniques we use for absolute dating. And the most important one probably for us is radiometric dating. Okay, so radio involves radioactivity or radioactive particle. Metric means to measure. Okay, so radiometric dating. It used the amount of a radioactive isotope to determine the age of something. All right, so we use radiometric dating for absolute dating. That's the technique. Now, it's important to point out the tool that we use is called a Geiger counter. It's a tool used in radiometric dating. And the way that it works is this probe can detect radioactive particles. And the number of radioactive particles is related to the age of something. Because as a radioactive isotope decays, so things will have elements that are unstable and they're radioactive, as they decay, they give off radioactive particles. And the amount of radioactive particles they give off can be used to determine, well, how much of the radioactive isotope you have, or you currently have, and how much was in the beginning. And you sort of use that ratio to give you a sense of the age, because if you have a lot of radioactive isotope remaining, then it's relatively young, because not much of the radioactive isotope decayed. But if you have only a little bit, then it's an older object, because a lot of it decayed. So that's for radiometric dating. All right, now that we've discussed the two different types of dating, let's take a closer look into radiometric dating. So we talked about radioactive decay. We'll talk about this Geiger counter again. So again, the radioactive decay is measured using a Geiger counter, which is a tool, and it measures the amount of radioactivity by counting the number of, and these are some of the radioactive particles. Alpha, an alpha particle. It uses this, I think that's a Greek letter, alpha. Beta particle uses the beta symbol. This one that kind of looks like a Y is called gamma. That's Gamma. It can also detect other particles like a neutron. Neutrons have a symbol with a little 1 on top, a little 0 on the bottom, and then an N, which is normal size. That's a neutron. Protons, that has a symbol of 1 on top, a 1 on the bottom, and a P. And there's other particles as well. And it counts the particles in counts per minute. The higher the count per minute, the greater the radioactivity. And then that, if it has a large amount of radioactivity, that means you have a lot of radioactive isotope remaining, and so that object is young. But if it has a little bit of radioactive activity, then you have fewer. All right, so this is the part of the notes that you should have. Again, if you need to, pause the video and copy the notes down. I hope you found this video helpful. Have a quality day.